Good morning, grade 5 Newton. Before we start our class, let us first have our opening prayer. Irish, could you please lead the prayer? Okay. So before we start, let us first check our attendance. So if your name is called, please say present. Ryan? Okay. So before I will present to you our short video clip about our topic today, let us first have our guide question. So first question is, what is force? Second, who formulated these laws? Third, what are the three laws? So please listen attentively.
Hello learners, this is Easy Engineering. Today we're going to talk about another fun topic in physics. It is all about the laws of motion. Have you ever heard of the three laws of motion? Here is a quick history about the three laws. The laws of motion are the relationship between the forces acting on the body and the motion of the body. These laws were first formulated by an English physicist, Sir Isaac Newton. These three laws were published in his book Principia in 1687. Now that we know the history of the laws of motion, let us tackle them one by one. Newton's first law is known as the law of inertia. The law of inertia was first formulated by Galileo Galilei for horizontal motion on Earth and was later generalized by René Descartes. So what is inertia? Basically, it is an object's tendency to keep doing what it's doing. The first law is stated as an object in motion will remain in motion and an object at rest will remain at rest unless acted upon by a force. And what does that mean? It means in order to change the way an object moves, a net force must be present. The most important thing to know about the first law is mass. You see, the more the object has mass, it would be harder to apply force to the object with more mass, and it would be hard to stop once it starts moving. To understand this, let us have an example. Let's say you have two balls of the same size but different masses, like a plastic ball and a bowling ball. Among the two balls, the bowling ball is going to be harder to move and to stop. It has more inertia because it has more mass. Now, on his second law, we're going to talk about the importance of the net force. Newton's second law talks about the changes that a force can produce on the motion of a body. It states that the time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. For a body whose mass is constant, it can be written in the form of F equals ma, where F is the force and a is the acceleration. Both are vector quantities. Now let's talk about when an object accelerates. When the forces are unbalanced, it means that the object is accelerating. The most common cause of an object to move is because of the gravitational force. When an object falls downward, it is accelerating downward at a rate of 9.81 meters per second squared. In our formula, it is F equals ma. The force acting on the falling object is gravity, which means that the formula becomes F equals mg, where g is the gravitational force. Okay? And among those forces, this force tends to be present at all times. This force will be discussed through Newton's third law. Newton's third law states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. The third law is also known as the third law of action and reaction. What does that mean? It means that when you apply force on something, it gives an equal amount of reaction force. Say you have a skateboard. Once you press your feet against the floor will have an equal amount of force to your feet. That is why you can move. That equal amount of force acting upon you is called as the normal force. The normal force is a force perpendicular to whatever surfaces your object is resting on. The normal force is unlike other forces since this kind of force can change its magnitude. What does that mean? Let's say that you have a piece of paper and a penny. You hold the paper on the air and place a penny on it. The penny applies a force on the paper and the paper applies an equal amount of force. Now you add another penny on top of the paper. The two pennies applied a force on the paper and the paper also applied force on the two pennies, which means that the normal force is doubled. And then you keep on adding pennies to the paper until such time there are too many pennies which cause the paper to tear. That's what happens when the normal force cannot match the force pushing against it. And that's it. Did you enjoy our
Okay, so based on the video that you have watched, so I will call someone. So, Rizal, what is force? Correct. So, force is anything that can change the state of motion of an object like a push or pull. So, force is using the direction and strength. In physics, force is any interaction that when unopposed will change the motion of an object. So, force also can cause an object with mass to change its velocity, which includes to begin moving from a state of rest to accelerate. And force has both magnitude and direction, making it a vector quantity. So for example, if we push a letter on the computer keyboard like this, so we are using a force. So next, when we kick a ball on the ground, so kicking a ball, we are using our force to roll the ball. Okay, so now that you have watched our short video clip, so I will call someone to answer our guide questions that lately I have given to you. So Giselle, first question is what is force? Correct. So force is anything that can change. It can change the state of motion of an object, like push or pull. Force also is using the direction and strength. In physics, force is anything interaction that when unopposed will change the motion of an object. Force also can cause an object with mass to change its velocity, which includes to begin moving from a state of rest to accelerate. And force has both magnitude and direction, making it a vector quantity. So for example, I have an example here. So if we push a letter on the computer keyboard like this, so when pushing a letter, so we are using a force. Second example, if when we kick a ball on the ground. So by kicking a ball, enable for it to roll, we need to use our force. The more force you will put, so mas dako yun or mas taas ang mag-abot sa ball. Next question. Who formulated these laws? So, the mastermind of these laws is Isaac Newton. So Isaac Newton is an English physicist who formulated these laws, and it was published in his book Principia in 1687. So the third question is what are the three laws? So the three laws. First is the law of inertia. Second, the law of net force. And third is the law of action and interaction. So what is inertia? The first law is stated that an object in motion will remain in motion, and an object at rest unless acted upon by a force. So, for example, we have a tennis ball on the top of the cup with water. So when the lady push the push the board sideward, so the tennis balls drop on the water. So when we use so the tennis ball is at rest. So when the lady push the board, so it has force. So it move. Next is the law of net force. So that determine the rate of change of momentum of a manual in both magnitude and direction to the force it will turn on it. So for the body whose mass it is constant, it can be written in form of F equals ma. So where F is the force and A is the acceleration. Both are vector quantities. So let us talk about when an object accelerates. So when the force are in bounds, it means that the object is accelerating. There must be common cause of some object to move. It is because of the gravitational force. So like the ball bounce. So when an object forced downward, it is accelerating downward in a rate of 9.81 meter squared per second. So it has acceleration, the ball that bounce and the ball that force downward. So the formula, in a formula, it is force equals mass and acceleration. The force is acting on the falling object is gravity, which means that the formula become force equals mg. So the g is the gravitational force. Did you get it, class? Okay, good. So the third law is the law of action and interaction. So Newton's third law states that when the two objects interact, they apply forces to one another that are equal in magnitude and opposite in direction. So the third law is also known as the law of action and interaction. For example, when you have a skateboard and once you press your feet against the floor will have an equal amount of force to your feet. That is why you can move. So that equal amount of force acting upon you is called the normal force. So it is also a force perpendicular to whatever surfaces your object is resting on. The normal force is unlike other forces since this kind of force can change its magnitude. So did you get it, class? Okay, good. So I will call someone to answer the following questions or the pictures that I will be presented to you. So are you ready? Okay, let's start. So what law of motion is presented on the video or on the clip on your screen? Yes, Jasmine? Correct. So, it is an example of the law of inertia because the thing that is rests on the top like the tennis ball, when you give a force, so it will move. Next. Yes, Leda. What law of motion is on the second picture or video clip? That's right. So it is a law of net force. Last, what law of force or what motion is presented on your screen? Yes, Trisha. Very good. So it is an example of law of action and interaction. Very good, class. So now I have a question for you. So let me have Giselle. Giselle, so what is our topic all about? That's right. Our topic is all about Newton's law of motion. Next. Yes, Joshua. What are the three laws of motion? That's right. So the three laws of motion is the law of inertia, law of net force, and the law of action and interaction. Very good. So now, please prepare a one whole sheet of paper and answer the following questions. So this is to test your knowledge or what you have learned in our discussion today. So we have seen that column A has a picture, so you need to match it on the column B. So it has a corresponding correct answer. So you have 5 minutes to answer. Okay. Are you done, class? Good. So for your assignment, cut a picture showing the three Newton laws of motion. So you need to paste it on a short bond paper, and you should be creative. So dapat nice inyong buhaton. So you need to picture out the three laws of motion. So that's it. Do you have any question, class? So if none, thank you for participating and enjoy your day. Goodbye.